Hey, everybody. Welcome back to Social Justice Math. We have our second entry in our voting kind of unit here. So last time we spent a bit of time talking about one very basic voting method and kind of how our voting system is going to work when we're discussing this in the class, talking about preference ballots and things like that. So what I want to do in this one is just take a look at a couple more ways that we can actually determine who wins a vote like this. And maybe more importantly, how can we determine if a way of counting these votes is actually fair? Right. So a couple things I want you to think about as we're starting this, right? First off, in a very general sense, right? What does fairness mean to you? What do you think fair means? And then in the context of an election, right, how does that translate? Right? How does fairness work in the sense of an election? As far as elections go, right, what would be the difference between an equal outcome and a fair outcome? So think about what those two things mean and what would be the difference between those two. And then start thinking about, now that you have kind of an idea of what you think fairness is, what kinds of things, right, would we want to aim for if we're trying to achieve fairness, right? And that can be either in terms of elections like we're talking about now, or fairness just in terms of kind of general ideas of fairness here, right? So I'm not going to harp too much on the definition of that because I think we'll see in a minute kind of how this is going to play out. So for now, just take your own internalized ideas of what fairness is and kind of keep that in the back of your mind as we go through these different things. So we're going to talk about two distinct things. One we've already talked about, and that's voting methods. And this is just a way of taking a preference schedule. So everybody votes, they list their preferences, we gather all that information, we put in a preference schedule, right? And then, right, we use that to determine uh, a winning candidate, right? That is the voting method, is how we count those votes. And the second thing is going to be what we call a criterion of fairness. So this is a way of giving a general rule of thumb for if we have a voting method, what should be the result if it's fair, or what are some guidelines that tell us that something would be fair or not fair, right? One thing I strongly recommend as you go through this video, it will help you tremendously later on, is we're going to have a bunch of different voting methods. We're going to have a bunch of different criteria for fairness. And so what I would recommend is keep a sheet of paper separate. Every time one comes up, write it down, and that way you just have it all collected in one spot, because that will make your life so much easier as we continue to talk about this stuff. So let's go back to what we talked about last time with voting method one. We have a majority, meaning more than half. But then we have another thing called plurality, which is just the largest amount of something, the largest proportion. So we developed something called the plurality method for voting, where we just looked at who has a plurality of first place votes. So which candidate has the most first place votes. So they don't need a majority here. They don't need more than 50%. They just need the most compared to everybody else. So a plurality. So that was one thing we did. So a good fairness criteria here might be, if a candidate has a majority of first place votes, they should win, right? Now, we're not talking plurality here. So remember, plurality method talks about plurality. So this is a little different. It's a little stronger, where we say if a candidate gets a majority of the first place votes, they should win. So that's going to be our first fairness criterion. And the plurality method actually jives really well with this fairness criterion. It does not violate the majority criterion, meaning if you use the plurality method, it will obey this fairness criterion. If somebody gets a majority of the votes, then they will definitely win in the plurality method. All right, so let's talk about another way to go about this. So a gentleman by the name of Condorcet stated his own fairness criterion that he thought made an election fair. And that was, if a candidate is preferred over all other candidates in a head-to-head matchup, they should win. All right, so if a candidate is preferred over all other candidates in a head-to-head matchup, they should win. So let's talk a little bit about what this means as far as a head-to-head matchup goes. So first, plurality, most amount of first place votes. So let's just look at our first place votes column, right? And the way we want to read this is this number up top indicates how many ballots we had of that type. So in this case, 5 people submitted the ballot where it was ranked A, D, B, C. 6 people submitted the ballot where it was ranked B, D, C, A. And then 7 people submitted the ballot was ranked C, D, A, B. Right. So there are 5 of these ballots, 6 of these ballots, and 7 of these. That means that A got 5 first place votes, B got 6 first place votes, and C got 7 first place votes. So 7 got the most of that. So that would be C. So C would end up winning by plurality. Now let's look at these head-to-head matchups and see what happens. So here's what we're going to do. All right, let's do A and B first. All right, we're going to do A versus B, and I'm going to look at each of these columns and say, okay, A was preferred over B 5 times. So in this first column, they ranked A higher than B. So that's 5 for A. So kind of what I'm doing here is I'm just ignoring C and D. I'm just looking at what happens between A and B. So 5 people prefer A over B, 6 people prefer B over A, and 7 people prefer A over B. So if I put that all together, this column and this column like A more than B. So that would be 12 total. This column likes B more than A. That would be 6. 12 is bigger than 6. So A wins in this head-to-head matchup, right? So we would prefer A over B here, right? So we have A over B. If we look for A and C, A is preferred to C 5 times, and then C is preferred to A in these last 2 columns. So that'd be 13. So C would win that one. You kind of see how this works out, right? So what you're going to find if you do this out is that D actually wins all of its head-to-head matchups. Right, so even though D only got second place votes, nobody voted in first place, we can see here that D is preferred to A, right? 5 people liked A over D, but 13 of them liked D over A. So D beats A, right? D beats B here and here. That's 12 people who like D over B compared to 6 who like B over D. So it wins against that. And then over here for C, right? D beats C here, D beats C here. That's 11 total. And then C beats D here. That's 7 total. So 11 versus 7. Well, D wins that one too. So it wins all 3 of its matchups. It beats A, it beats B, and it beats C, right? So if we use plurality, then we automatically get that C is the winner. But these head-to-head matchups tell us that D should be the winner. D is preferred to everything. If you gave the entire group of voters here the choice and said, like, hey, which would you prefer, D or C, right? They would say, well, we would prefer D, right? So this is an issue, and that means that the plurality method violates the Condorcet criterion. So the plurality method, if we use that, is not going to obey this head-to-head matchup rule. Okay, so now we're starting to refine things a little bit, right? We have this Condorcet criterion, so we have another criterion for fairness. The plurality method violates this. So something we think would make an election fair, well, this method wasn't working. So let's see if we can design a new one, right? Can we make a new method that is okay with the Condorcet criterion that would satisfy it? And we're going to call this one pairwise comparisons, or we can call it the Condorcet method. However you want to do it, it's just referred to as both. And this is how we're going to do this voting method. We're going to construct all of our head-to-head matchups. So just like we did, right? If we have A, B, C, and D, we'll do A versus B, A versus C, A versus D, and then you'll do B versus C, B versus D, and then C versus D. So there's going to be a lot of things I'd recommend writing them all out and kind of keeping track that way, because it can be a lot to keep track of in your mind. So we're going to construct all of these, and then we're going to see who wins each one. If a candidate wins a head-to-head matchup, they get 1 point. If there's a tie, we'll give them each half a point. And then at the end, most points wins. So let's look at this. We have an NFL draft scenario. We have 5 college players that our team is interested in, right? And we've taken a poll among all of our scouts, coaches, and managers to try and figure out who we're going to select with our first pick in the draft. So we have 5 players here, A, B, C, D, and E, right? And we have this setup for our preference schedule. So 2 of them submitted this preference where it's D, then E, then B, then A, then C. 6 submitted this one, 4 submitted this one, and so on and so forth. So we have, it looks like 22 total voters here, right? So the way I like to think of this is 22 total voters. In order to win a head-to-head matchup, you would need 12 votes. So you need to be preferred over something else 12 times in order for that to work. So let's do one of these, and then I'm going to leave the rest to you and see if you can figure out what happens. So let's do A versus B, right? Okay, B is preferred to A 2 times. A is preferred to B 10 times between these 2 columns. Okay, so A is preferred to B 10 times. We only need 2 more wins for A, and they get it. So let's see. In this column, B is preferred to A, B is preferred to A in this one, B is preferred to A in this one, B is actually preferred to A in this one. Okay, so these are the only 2 columns where A actually beats out B. In the first column, the 4th column, 5th, 6th, and 7th, it's actually B who wins. So we can add those up. 2 plus 1 plus 1 is 4, plus 4 is 8, plus another 4 is 12, right? So, okay, cool. That means B is preferred to A, right? So in that head-to-head matchup of A versus B, we would give B the point. That would be our candidate that gets the point. So I'll let you work on this on your own. If you work this out, you will find that the Condorcet winner is player D, right? So that is the player that we are going to pick first in the draft. Now, let's say that there's a slight hiccup with this, because of course, there's always going to be leaks when it comes to things like this in sports. So somebody posts on Twitter that we're planning on selecting player D, and then knowing that he's not going to get picked number 1, player B decides, I'm actually going to go back to college, finish out my senior year, and see if I can raise my draft stock. So now, all of a sudden, player B is gone from our choices, right? So everywhere they're ranked, it's like we can just eliminate them and kind of shrink everything down. So if we remove player B from the preference schedule, right, we can rewrite it out and recount the votes. Now, the order of anything else isn't going to change. We're just going to get rid of wherever B is. So if we get rid of B here, A and C will shift up. So the preference here will go D, E, A, C. Okay, and it'll just shift up like that. And when we do this, we might find that some of them are the same again, depending on how things are slotted, depending on what goes away. So you may be able to shrink down your preference by a little bit, combine some of the columns, but do this and then see if you can figure out who wins. Go ahead and pause here so you can do this for yourself, and then I will let you know that, in fact, A and D will tie in this. So this is interesting, right? We had a player that wasn't going to be our pick. They left. We should probably still pick the same person, right? But it turns out all of a sudden now it's a tie. Now it's a tie between A and D. Okay, that's interesting. Well, this gives us some motivation to maybe come up with a new fairness criterion, right? If we have a winner of an election and we do a recount where one of the non-winning candidates is removed, then the winning candidate from before should still win, right? So we call this the independence of irrelevant alternatives criterion. So it's quite a mouthful. You can abbreviate it IIA if you want, or you can just call it irrelevant alternatives. So what this says is that if we get rid of an irrelevant alternative, so one of the candidates that didn't win, the results of the election should be independent of that, meaning the same person should win. So we just found out that if we use the Condorcet method, this is going to violate our IIA criterion, right? It's not going to obey it because in the last one, the same person didn't win. We ended up with a tie, right? So let's try something else. Let's see if we can make this work, right? Let's look at the board account method. This is the one you may be the most familiar with other than plurality. And what we're going to do here, when it's written out, it looks a little confusing, but it's really not that bad. Every last place vote is going to be 1 point. Every second to last place vote is going to be 2 points. And then we're going to count up like that until we get to our first place vote, which is going to get n points, however many candidates there are. So if we had 4 possible candidates, the lowest one would be 1 point. Second to last place vote would be 2 points, then 3 points, and then a first place vote would be worth 4 points. Right? Do that, add them all up, see who wins. Okay, so let's look at this board account method in action. So here we have a pretty simplified preference schedule. Let's see if we can practice some of these other ones. So again, pause here if you'd like. This would be a good one to look at to make sure all these ideas are sticking. Okay, and we're good. So plurality, if you use this, A should win. And this one's pretty easy to see, right? Go to the first place. A gets 6 of the votes. B gets 5 of the votes. C gets none of the votes. D gets none of the votes. Right. So A has a plurality of votes here. They actually also have a majority. So yeah, they win by plurality. With Condorcet, A actually wins as well. You can see this if you look at the first 2 columns. A is going to beat out everything here. That's 6 total votes. And then everything is going to beat A over here, but that's only 5 total votes. So A is going to win all of its head-to-head matchups. So it's definitely going to win Condorcet. And then if we use board account, this is how we would do this. So let's take A, for example. A has 3 plus 3, so 6 total first place votes, right? So if we count up, last place gets 1 point, third place gets 2 points, second place gets 3 points, and then first place gets 4. So we kind of just flip-flop our order here. So we have 6 times A got first place, and those are each worth 4 points. So if we do 6 times 4, that gives us 24 total. So these 2 columns are worth 24 points. And then A's in last place here. It got last place 5 times. So we have 24 from this. Each one of these is worth 1 point. So that would be 5 total points. So 24 plus 5 would give me 29 total points for A, right? So that's how I'm going to sum all these things up, right? That's what we're doing with this. For B, it gets second place here, and first place here. So 6 total second place votes. So that would be 6 times 3. So that's 18 for its second place votes. And then it has 5 first place votes. Each one of those is worth 4 points. So that's 20, right? So that'd be 38 total points. Okay, well, you can do this for C and D, but I'll go ahead and let you know that B is going to be our winner here. So plurality, A wins. Condorcet method, A wins. Board account, B wins. And you can see kind of the difference here. Even though B had less first place votes than A, when people didn't pick B first, it was preferred much more than A was when it didn't get first place. So you can kind of see how that ends up working out in this scenario. But what does that mean for fairness criterion, right? What does the board account method violate? Well, both majority criterion, because plurality didn't work, Condorcet, because Condorcet didn't work. So it definitely violates those 2. Right. So let's see if we can come up with something else, right? We're already 3 voting methods deep in this. We haven't found anything that satisfies all of our voting criterion yet. So maybe the answer here is just to go back to where we started and see if we can mix it up a little bit. So here's what we're going to do. We're going to go back to plurality, but we're going to do it in stages, right? We're going to look at the first place votes and see if a candidate has a majority. So not just a plurality, but a majority. So more than 50% of the votes. If they do, they win, we're done, right? If not, we're going to eliminate the candidate with the fewest first place votes. So we're going to take them out of the running, right? We'll shorten our preference schedule just like we did with our NFL draft example. And then we'll look at the first place votes again, right? Count them up, see if somebody has a majority. If they do, they win. If not, we'll just repeat that over and over again. We'll remove the candidate with the fewest first place votes and so on and so forth. So let's take a look at an example here. Let's say we are trying to decide where the next Olympics is. We have three possible cities. We have Athens, Barcelona, and Calgary. And so these are the polling results, right, for our preference schedule here. So this is before the actual vote takes place. They take a kind of a straw poll and just see how everybody's thinking. And this is what they're able to come up with, right? So with this, if we use plurality with elimination, let's see who wins. So we're looking for most first place votes. That's going to be A with 11, right? B has 8, C has 10, A has 11. Now, how many votes do we have total? It looks like we have 29. So 15, 25, 29. Yeah, it's 29. So we need a majority here. So we need at least 15 votes to get a majority, right? Half of 29 would be 14.5. So we need 15 to be more than 50%. Okay. Well, that's fine. We don't have that majority yet, right? A has the most votes, but it's only 11. So let's go to the least number of first place votes. That's B. And we're going to get rid of it. Right. So B is going to vanish from this. Now, what that means is that this is going to slide up. Right. So it'll look like AC, CA, CA, AC, right? All the B's just vanish. And now we only have two possible choices, right? Either Athens or Calgary. Okay, so let's see if somebody has the most first place votes now. So A still has 11, C has 10, and they actually get these as well because B's gone now. So this scoots up. So C actually has the most first place votes here with 8 plus 10, 18, and that's more than 15. Well, there we go. That's a majority. So Calgary is going to take it. That's where our next Olympics is going to be. Well, let's say the 4 voters in our 4th column. So if I go back, that would be these right here. They preferred Athens to Calgary, but they preferred Calgary to Barcelona, right? So they decide about this poll. They're like, well, shoot. I mean, Athens isn't going to win. So let's at least get Calgary, right? Let's make sure that Calgary is the place that this goes. So they switch up their rankings. So Barcelona still last for them, but they put Calgary first, and then they put Athens. So they switch it up, and that gives us this preference schedule. They say, okay, we're going to join in with this crew over here. We want Calgary first, then Athens, then Barcelona, right? We know Athens isn't going to make it, so let's just join Calgary, right? If you can't beat them, join them. So we have this. Who wins with plurality with elimination here? Well, A has 7, B has 8, C has 14. 14 is not quite a majority. It's close, but it's not quite there, right? We need 15 for a majority. So we get rid of the lowest number of votes. That's A, lowest number of first place here. A goes away, A goes away, A goes away. Shrink down your preference schedule, squish it. And so we look at first place votes again. C still has 14. B has 8 here, and then this scoots up, and B has 7. So B would have 15 total. Well, that's a majority, right? There we go. B wins. Okay. So C won before, Calgary won before, and then a bunch of people who voted for Athens was like, well, we just don't want Barcelona to be it, right? So let's switch our vote to Calgary, right? And so we had Calgary winning, a bunch of people switched their vote to Calgary, and then Barcelona won. So this is what we call the monotonicity criterion, right? Or at least this is what inspires it, right? So this is a fairness criterion that says if you have a winner of an election and in a re-election, the only changes that happen are in favor of that candidate, then they should still win, right? We started with an election. Calgary won. We did it again, but the only changes were in favor of Calgary. More people picked it first, and then somehow Calgary ended up losing. So we call this the monotonicity criterion, right? So this is our fourth fairness criterion here. So now I'm going to turn it over to you to work on this. I've left you with a bit of a puzzler, right? Because we have 4 voting methods and 4 fairness criterion, and we don't yet have a voting method that satisfies all of those fairness criterion. So that'll be something we'll have to investigate in our next lesson. But for now, go ahead and practice, make sure you're okay with these voting methods, go back and use the examples we talked about, and I will see you all in the next one. Thank you for your time.